Okay, everybody, this is day 12 of our SOL review. We're talking about functions and the transformations. For Wednesday and Thursday's assignments, you're going to have a warm-up, an exit ticket, and a Desmos activity. You have to turn in all work by May 29th. That's not this Friday, but next, for your final working period for grade. So my grades are due June 2nd, but the cutoff for you to submit is May 29th. Now, that's going to include days 5 through 12. Anybody who has already done days 1 through 2, 1 through 4, you already get credit for those, but I am no longer taking those as submittals. If you've waited to submit, you cannot go back and do days 1 through 4. I have cut those off because of their lateness and because the first 2 days were not part of the alternative learning plan. So if you did them, you got credit. If you didn't do them, you don't get a 0 on days 1 and 2 only. If you fail to do 3 and 4, then you need to pick up and do days 5 through 12. Please meet deadlines. Every one of you who has waited until you got a 0 in the grade book before you decide to go back and do the work, that's on you. You guys have got to be more responsible about getting this work in on time. So when I ask you to show your work, I'm not saying tell me that you did it in a calculator or Desmos. That's not showing work, and don't talk me through it logically either. If I show you how to do the work in these videos, that's what I expect you to give me in your return work. Don't just make something up and say, well, I didn't watch the video, so I don't know how to do it, because you should be watching these videos. And if you don't show work, you get a 0 and you will not get to resubmit, because I'm tired of people waiting to see how little they can give me before I'll give them credit. You get 1 submit and 1 submit only per assignment. Many of you have missed the Mastery Connect Common Assessment 1. I have reopened those. For those of you who have not taken it yet, here are your codes. Do not use any other day code but your own class code. Common Assessment 2 is still open. I extended the window, so you need to go to day 10 in your Google Classroom to get your code for your classroom. If you missed the quizzes on day 7, and there was only 1 quizzes from days 4 through, then this is the code you can use. Do not retake. I will not count a retake grade for those of you who have already taken it and want to try and up your grade. So do not retake it if you've already got a day 7 grade. Here are the 5 common parent functions, and actually I threw in a 6th. Linear, it's a straight line through the origin, that's the parent. Quadratic, it's a parabola through the origin. Cubic, it has a kind of an S shape through the origin. Square root, it starts at the origin and is like a half of a parabola on its side. Absolute value is a V through the origin, and the inverse function are 2 branches where the asymptotes are the X and Y axis. So for the inverse function, you get a 1 over X. For the absolute value, you get the absolute value of X. Of course, for the square root, you get the square root of X. For cubic, you get X cubed. For quadratic, you get X squared. And for linear, you get Y equals X. So those are your 5 common parent functions. Now, we did this with the absolute values only. We said if you put a number inside the absolute value bars next to the X and you say plus C, it actually moves this whole parent left C unit. So if that's a plus 3, this parent would move left 1, 2, 3. Even though it says plus, you know when you're inside the absolute value symbols, you actually move in the opposite direction. When you go outside the absolute value symbols, then you go up or down, and you go in the correct direction of the sign. So if it says positive C, you'd go up C. If it said negative C, you'd go down C. Well, that's no different for quadratics, cubics, and square roots. If I put the number inside parentheses, then that's going to be a left or a right move. If I put it inside the square root bar, it's going to be a left or a right move. If I put it outside, it's going to be an up or a down move. So here is an absolute value graph. You can see that the vertex is at 3, 4. So notice that this absolute value bar has to have the H variable values. We call the vertex H comma K. Actually, call the vertex HK. So H goes here and K goes here. Now for the slope, you have count from the vertex to any point that crosses another, I guess where the grid lines cross. So I went down 1 and over 2. So that's a rise or a fall of 1 and a run of 2. So that's a 1 over 2. And because the absolute value bar is upside down, we put a negative sign in front. So this would work for a parabola, a cubic, or a square root one as well. So here, it looks like my vertex is -1, 2. So if my vertex is -1, 2, then h goes inside the absolute value bars. So that would be x minus -1 or x plus 1, and then plus 2 goes on the outside. And because it's not flipped and because it's 1 to 1, you can see you go up 1 and over 1, then that slope in front would just be a 1. Okay, here, it looks like my vertex is 2, 3. So it's going to be a -2 inside the absolute value bars and a +3 outside. And then if you look at your slope, it goes down 2 and over 1 to get that in the next grid crossing. So that would be 2 over 1 or 2, and the negative sign says it's flipped upside down. Okay, this one has a vertex of 3, 0. So you would have x minus 3, and then it would say plus 0 on the outside, but you don't need a plus 0. And of course, the slope is up 1 over 1. So the slope in front would be 1, and you don't need to write that. Okay, here you have a 5, 0 for your vertex. You always need your h and your k. 5 is h, k is 0. And so I'm going to have an x, negative x. Sorry, that's 0, 5. No wonder. This point is 0, 5. So I'm going to have an x minus 0 plus 5, and you don't have to say minus 0. And because it's upside down, we put a negative, and you notice there's a 1 to 1 rise and run, so the slope in front would be 1. And I think I'm just going to uncover this one and let you guys figure it out. And I'm going to cover this one as well and let you figure it out. Okay, so your vertex is -4, 1. So -4 goes inside, so that would be x minus -4 or x plus 4, and then plus 1 goes outside, and of course it's upside down, so you put a negative in front, and it's a 1 to 1 rise over run. Okay, oh, I didn't realize I had so many of these. Okay. Okay, so of course for an absolute value, we've been doing these all along. This would be x minus 3 plus 2, and then it's negative because it's flipped. So for a quadratic, I also have a 3, 2 vertex, and it doesn't look much different from the absolute value, except I put in parentheses instead of absolute value bars, and everything else is the same except for the squared outside the parentheses. So that's how you would do it if it were quadratic. So you should be able to do this without a calculator. Turning points. So when you have a linear function, that's y equals x to the first power, there are 0 turning points. It never goes from going up to going down. So if you say 0 turning points, then you have to have a 1 power on the x. Well, if you have 1 turning point, it was going down and now it's coming up, then you say that has to have a second degree. That's how many turning points plus the number 1. So if I say 1 turning point plus 1 is 2, it would be a quadratic. Here I have no turning points or 2 turning points. So if it's either 0 or 2, then my degree has to be 3 because you always have 1 more than the number of turning points. So if I have 2 turning points, I would have a 3rd degree, or no turning points is also a 3rd degree. So what degree would I put on this x? Well, let's count. 1, 2, 3, 4, 5 turning points, so I have to say 5 plus 1 is 6. So this would be a 6th degree polynomial. Okay, so you have a warm-up ticket and an exit ticket. Look how easy these are. For this one, you're just telling me what the equation is by first labeling the vertex hk and then figuring out which one of these has the correct hk, and because it's flipped upside down, there should be something in front of the bars. Which one of these is the correct function? Well, this looks to me like a square root function, so you should be able to get that. Name this function, name what you see here, go back to the first page where we named all 6 functions. This one, you know it's one of the functions, but you have to give me the asymptotes and figure out how those asymptotes work. And then here, they're asking you which of these would be the correct degree based on the number of turning points in this polynomial. Okay, so you have a warm-up and an exit ticket, which were on this page, and I just showed you that, and you have a Desmos activity called transform a parabola. So you have those 3 things to do for the assignment, and I will see you guys next week.